To summarize, let's put a big picture right here. This is going to be the range of inverse functions. If you took my class last year, hopefully you remember this picture. We're going to write sine like that. Look at this, cosine fits so nice, and then we're going to put tan right there to make this cost across the x-axis. That's a really easy way to remember the range of the inverses. Now we're going to do a bunch of compositions of these. So now we see the functions within the function. So the first thing I want you guys to do is to classify these. There are two types of questions we're going to do. Letter A is an example of a triangle question, meaning the inverse is on the inside, sorry. Letter B is where the inverse is on the outside. We're going to call those circle questions. Okay, so let's quickly classify these. So triangle, circle, inverse is on the inside here, so we're going to call this a triangle question. Inverse is on the outside, so that's a circle. Inverse outside here, so we'll call this circle. Let's first start with the triangle questions, because those are pretty easy. It says cosine inverse of 0.6. Let's first make that a nice fraction. Cosine inverse of 3/5. What you want to do is understand that this thing right here, this little piece, is some angle theta. So all you do is you draw it. Now if the range is quadrants 1 and 2, it's positive 3/5, which means your triangle should be right there. 3, 5, 4. There's your theta. So now it's saying, well, what is cosine of theta? Look at the triangle. It's 3/5. Now you're probably wondering, why didn't we just cross it out? And that is true for this particular problem, you could, but you have to understand the theory, because if you look at letter C, look at what happens here. If we do the exact same method, let's make that 3/2. This is 3 and this is 2. If you were to cross out and write 1.5, you definitely get it wrong. You have to realize that this triangle is impossible. It's impossible because the hypotenuse is too short. It can't be 2 if a leg is 3, which means this one there is no solution. So that's why you don't just want to cross it out mindlessly. You have to understand exactly what you're doing. Now for the circle problems, I'm going to show you a couple techniques here. The first technique is the easiest. You just evaluate this inside part. So evaluate. You guys should know what that is. That's simply -1. And now it's exactly like the things we were doing earlier. We're going to highlight quadrants 1 and 4. -1's down there. So to get there, that angle, that's -π/2. Done. For tangent, same thing. Evaluate that thing. Tan of 5π/6, that is -√3/3. So now we're going to do tan inverse of that. We highlight quadrants 1 and 4. -√3/3 is right there, which means the answer is -π/6, or -30 degrees. So not too bad, right? We just evaluate the inside and then do what we were doing on page 1. Now it gets a little harder if you get something like this blue box. The limitation on this method I just showed you, is what happens if you couldn't just evaluate it. Well, in that problem, in that sense, you have to draw it. So let's highlight 1 and 4. 5π/8, that's going to be in quadrant 2, a little past right there. So we can see we are not in the range by drawing it out that way. But what we can do is use reflection. So for sine, you simply reflect over the y-axis, because that's not going to change the y value. And by reflecting it, we're going to put it within the range. So now we have, if you reflect that, that new angle is going to be 3π/8. And that's because if you think about this full rotation here, this would be 8π/8. So this angle here should be the same as this angle here. They're both 3π/8. Which means I can rewrite this question as this: sine inverse of sine of 3π/8. Now we can cancel it out because we are in the range, and 3π/8 is our answer. So that's going to be more of an advanced question. Okay, so here's a couple more examples. I know this is kind of hard, so we'll do a couple more examples to make sure we're okay. Let's quickly classify these. So this one, we can see the inverse is on the outside. This makes it a circle question. I'll just put a circle. Inverse inside, so triangle. Inverse outside, circle. Inverse inside, triangle. So the triangles we'll do first, those are easy. So again, you could just draw the triangle. I'll draw triangle quadrant 2, because it's negative. So I'll put negative 0.41. Cosine of this, that's just negative 0.4. So basically they cross out. Now this one's kind of tricky because pi, remember that's just a number. So let's just make that pi and 1. Pi is about 3. So we can see that this thing is impossible. There is no solution here. Now for the circle ones, let's do the easy one first. Let's evaluate part C right there. So if we evaluate this thing, the cosine's even, so negative doesn't matter, cross it out. Cosine of 2 pi over 3, that'd be negative 1/2. Now we evaluate the inverse of negative half. Draw your circle. That's right there. And look, you get 2 pi over 3. No problem. Now the last one, this is the more advanced one. So pi over 12 we have to draw. Hopefully we know that's somewhere in quadrant 1. Notice how we are in the range, which means we're good. Just cancel it out. You get pi over 12. That's your answer. Okay, final part. So now we have triangle problems if the functions don't match up. So again, this is no problem. Look at this inside part. That's your angle theta. Tan is quadrants 1 and 4 for the inverse. So it's positive 5/12, which means this has to be in quadrant 1. 5, 12, 13. Here's our theta. Now we want cosine theta. So just do A over H. That's going to be 12 over 13. Done. Now the final one is going to be using algebra. Notice how, again, this is a triangle question. Okay, sorry, triangle here. This is a triangle question, but we have an x. That's okay. Just think of it as x over 1. So here's my triangle. For variables, you can typically just assume they're in quadrant 1 to make it more simple. So x1. Now you got to figure out this side. So if you're good at this, you might be able to do it in your head. Otherwise, just write out what I'm going to write out here. Question mark squared plus x squared equals 1 squared by the Pythagorean theorem. So question mark squared should equal 1 minus x squared. The question mark should be the root of 1 minus x squared. So I'm going to erase that. This should be the root of 1 minus x squared. Now we're going to figure out if this thing was theta, that's a triangle we just drew. So cosine of theta, that's going to be adjacent over hypotenuse. That's just the root of 1 minus x squared over 1, which is the root of 1 minus x squared.